Welcome everybody. We've been given this question: integral 0 to pi over 4 tan inverse of 2 times cos square theta divided by 2 negative sin 2 theta times secant square theta d theta. So what I wish to do is I want to first consider this part: 2 times cos square theta divided by 2 negative sin 2 theta. Then I wish to rewrite sin 2 theta as 2 times sin theta cos theta. Of course, you have 2 times cos square theta in the numerator. Then I would like to take 2 out. This would give me 2 times of 1 negative sin theta cos theta. In the numerator, you have 2 times cos square theta. 2 gets cancelled, giving me cos square theta over 1 negative sin theta cos theta. Now what I wish to do is to divide the numerator and the denominator by cos square theta. So this is going to give me cos square theta over cos square theta divided by 1 over, so this is actually 1 negative, let me write that step, sin theta cos theta, right? So this is being divided by cos square theta. So this can be further rewritten as cos squared gets cancelled, so it's going to be 1 over. I wish to split this as 1 over cos square theta negative sin theta cos theta divided by cos square theta. So this is rewritten as 1 over. 1 over cos square theta is secant square theta. Now you have a cos and a cos getting cancelled, giving me sin over cos. That is going to be tan theta. So all of this actually is a representation for this quantity. Okay, so let me rewrite the integral. So hence, what do we have? I is equal to integral 0 to pi over 4 tan inverse of 1 over secant square theta negative tan theta times secant square theta times d theta. Now what I wish to do is, I know a formula, secant squared negative tan squared is equal to 1. So secant squared is equal to 1 positive tan squared. So take the representation for secant squared and then you replace it with 1 positive tan squared theta. So 0 to pi over 4 tan inverse of 1 over 1 positive tan squared theta negative tan theta times secant squared theta d theta. Now let us make the following substitution. Let me move to the next side. So what do I have? I got the integral 0 to pi over 4 tan inverse of 1 over 1 positive tan squared theta negative tan theta times secant squared theta d theta. So let me make the following substitution. Let tan theta be equal to t, and then you differentiate tan theta. You get secant squared theta d theta is equal to dt. So when theta is equal to 0, what happens? T will be equal to 0. When theta is equal to pi over 4, what do you get? T to be equal to 1. So the integral is now going to be I is equal to integral 0 to 1 tan inverse of 1 over 1 positive. This is t squared negative, in place of tan theta it's t, secant square theta d theta. What is that? That's dt. So this is what you got. Now what I wish to do is, I would like to take t out. Now if I take t out, what do I get? So this is equal to integral 0 to 1 tan inverse of 1 over 1 positive t of t negative 1, fair enough. And then you have dt. Now I want to have something in the numerator. Now the idea is, I want a summation of two quantities. Now since I have a positive sign here, so this is obviously going to be a difference of two terms divided by one positive, the product of two terms. So whatever term that is present here should also occur here, right? So that I can apply the formula of tan of a negative b. So this is the objective. So to achieve that objective, what I wish to do is, I will have to have a t and a difference there. I already mentioned to you why I'm actually focusing on obtaining a difference is because of the fact I already have a summation here. So I can't do anything about it, but I will have to work with that. So this is equal to 0 to integral 0 to 1 tan inverse of. So I want to place a t there, follow it up with a negative sign, and then t negative 1. So negative being distributed with t negative 1 will give me negative t. So positive t and negative t will be cancelled. That is followed by a positive 1. So we are not doing anything, but we are actually retaining the original system, but manipulating it so that we can apply this formula. Okay, so in the denominator I've got 1 positive t times of t negative 1 times the dt. Okay, so the objective is to bring this tan of a negative b. So let me just write this formula. So tan of a negative b is equal to tan a negative tan b divided by 1 positive tan a tan b. Okay, so according to this, what do I have here? I got tan a to be equal to t and tan b is equal to t negative 1. So from here, what is a? A is nothing but tan inverse of t, and b is nothing but tan inverse of t negative 1. Okay, so what we can do is we can actually represent the system with this tan. If I were to do that, this tan inverse will usually be, what do I say, it will be absorbed out. So let us achieve that. Now, as I mentioned to you, I'm going to have here t, and I'm going to have excuse me, t negative 1. I'm going to have 1 positive tan a is going to be t, tan b is t negative 1. Over here, this is going to be what? Tan of a negative b. My a negative b is tan inverse. I need to squeeze it here. So let me write that tan inverse of t followed by negative tan inverse of t negative 1. So this is what I've got. Now I need to rewrite this, okay, for better clarity. That is our objective, right? So tan of a negative b is equal to tan a negative tan b divided by 1 positive tan a tan b. As I mentioned to you, along this lines, this is going to be t negative of t negative 1 divided by 1 positive t times of t negative 1. Okay, so I have a tan of a negative b. Now I can make the substitution for tan of a and b. So that's going to be tan inverse of t followed by tan inverse of t negative 1. So this is what I've got. This is equal to t negative 1 divided by 1 positive t times of t negative 1. Now instead of this, I can add this, isn't it? Okay, so go back to the question. So if I were to take this as 2 in place of this, therefore 2 can be rewritten as, what is it? Integral 0 to 1 tan inverse of this one, tan of tan inverse of t negative tan inverse of t negative 1. Okay, and you have dt there, and other things is taken care of. Okay, so this is reduced to this representation. Now clearly you see your tan inverse and tan, they get neutralized. So leaving us with integral 0 to 1 tan inverse of t. Now I want to make some slight change here. Now instead of writing it as tan inverse of t negative 1, I'm going to write this as tan inverse of, I'm going to take a negative sign out, so this is going to become 1 negative t. 1 attacks, or negative 1 attacks, this operates on 1, I get negative 1. Negative 1 operates on negative t, I get positive t. Now you might be wondering, why am I doing it? And you will know in a minute. So this is multiplied with dt. Now this is actually this negative sign. I can bring this negative sign. The negative sign will still be a negative sign, right? Even when it comes out, right? Tan inverse of this negative, of this 1 negative t, when it comes out, it will still be a negative sign. So that negative and this negative will become positive. So this is going to be integral 0 to 1 tan inverse of t positive tan inverse of 1 negative t times dt. Okay, now what I wish to do is I will like to apply this property, integral a to b f of x dx is equal to integral a to b f of a positive b negative x times dx, right? Where do I want to apply? I want to apply to this integral. So this is actually integral 0 to 1 tan inverse of t times dt positive integral 0 to 1 tan inverse of 1 negative t times dt. So let me go to the next slide. So as I mentioned to you, this is going to be 3. So 3 is rewritten as, so let me retain this tan inverse of t dt positive as this. So this is going to be utilizing this property. So integral 0 to 1 tan inverse of, so this is going to be my x, right? So it's going to be 0 positive 1 negative t times dt. Okay, so you can take a look at this property. So the limits are added followed by the difference of the parameter. Okay, so the difference of 1 negative t, that's exactly what is happening here. So this is equal to integral 0 to 1 tan inverse of t dt positive integral 0 to 1. So this we need to simplify. 0 positive 1 is 1, negative 1, negative into negative is positive t. So this is what we get, okay, times the dt. So positive 1 negative 1 goes off, giving me integral 0 to 1 tan inverse of t dt positive integral 0 to 1 tan inverse of t times dt. So this is what we have got. So now we will have to add these two things. So if I were to add these two things, so this is going to be integral 0 to 1. I add these two things, so 2 times tan inverse of t dt, and on the left I got I. So now, excuse me, we will have to use integration by parts. So I will take u is tan inverse of t. Now du is equal to 1 over 1 positive t squared times the dt. That's the differentiation. Now dv is equal to dt. So v is going to be t. So what is the formula for integration by parts? uv negative integral v du, isn't it? So my u is tan inverse of t, my v is t. So you place the limit 0 to 1 and followed by negative integral. My v is t here, and then it's du. It's going to be dt over 1 positive t squared. So dt over 1 positive t squared. So this is what we've got. Now let me show you the integration of this one. So t times dt divided by 1 positive t squared. So let me take 1 positive t squared is equal to p. So this is going to be 2 times t dt is equal to, I differentiate this, I get dp. So this is equal to dp over 2, right? So it's going to be 2 here. So 1 positive t squared is equal to p. So this is going to be 1 over 2 ln p. So the limits are there, right? The limits are 0 to 1. So we will have to substitute the limits. No, the limits we will have to, so 0 to 1, the limits have to be changed, isn't it? Because when we substitute 0, when I substitute 0, I get 1 here. But when I substitute this one, I get 1 positive 1, 2. Okay, so this is going to be 1 over 2. I substitute the upper limit, I get ln 2. I substitute the lower limit, I get ln 1. Now my ln 1 goes off, this is 0. So this is going to be 1 over 2 ln 2. So I can take this 2 on this end, this 1 over 2, I can push it off. That would give me ln of 2 raised to the power 1 over 2, which is going to be ln of root 2. Okay, so what I can do is, I can come over here, I can substitute the upper limit for this. So that's going to be 1 times tan inverse of 1, negative 0, everything goes off, followed by negative of, this is going to be ln of root 2. Now tan inverse of 1 is pi over 4. So it's going to be pi over 4 followed by ln of root 2. So after getting this result, what are we to do is we will have to go and substitute this over here. So if I were to make this substitution, this is equal to 2 times of pi over 4. Now initially, if you remember, I had done this, I pushed this off to the index of 2. So we don't have to do that. We can just retain it as it is. So this is going to be 1 over 2 times ln 2. So 2 comes inside. As 2 comes inside, this is going to be equal to pi over 2 negative ln 2. So this will be our solution. So please like, share and subscribe. Thank you everybody.